Okay, we're going to get started. Again, my name is TJ Willits from Veolia Water Technologies, and I'd like to welcome you to today's Veolia Water Tech Talk entitled Reducing Wastewater Treatment Costs with Advanced Evaporation Technologies. This is our first webinar ever that we put together specifically for the metal manufacturing, surface finishing professionals. So it's going to be really interesting to present content related specifically for the various companies within this industry. Before we get started with our technical presentation, just some handful of slides to go over. Obviously, you should be hearing me speak now. If you're having trouble, there are two audio options to choose between. You can either listen to your mic and speakers on your laptop or computer. If there's an issue with that, we also have an option. You can switch over to the phone call method and then use your telephone or cell phone to listen to the audio portion of today's webinar presentation. Just to note that everyone's microphones are automatically muted. There's a lot of people on the line. And this webinar is being recorded, and we'll send it out probably tomorrow, a copy of today's broadcast for you to review and also share with colleagues or just watch again. Now, though your microphones are muted, we want to make this webinar as interactive as possible. There's a question panel on the right side of your screen. If you have a question at any time throughout today's presentation, go ahead and just log it in to the question box there, and we'll put it in the queue and try to get to as many of those questions as possible at the end of today's broadcast. Now, this Veolia Water Tech Talk is part of a larger Veolia Water Tech Talk program. We do have another webinar coming up in the summer here. It's on Tuesday, June 28th. And it's on removing selenium from industrial wastewater. So if you or a colleague has any issue with that particular issue, feel free to go over to our website, log on, and register for that webinar as well. And also, we archive all of our tech talks, and you could go to our website again, and we have about 50 plus webinars available on demand that you could watch and as a part of your own continuing education goals and learn a little bit more about many different topics related to water and wastewater treatment. And if you want to use this webinar for participation or continuing education credit, we will automatically email a PDF of your certificate. It'll come out in about 24 to 48 hours after the broadcast ends with your name on it. So go ahead and look for that in your email. If you have any issues, feel free to give me an email, and I'll give that out at the end of today's presentation. Now, the feedback from you is very important as we do these. Just to help encourage you to go ahead and take a survey after the webinar. It takes about 1 minute to fill out. We're going to register everyone who does that for a $25 Amazon gift card. But we want to learn what we can do better to improve it, maybe what topics you want to learn at upcoming Tech Talks. That way we can continue to improve these educational events as best as we can. So before we get started again, just a little bit about Veolia Water Technologies. We focus on providing water and wastewater treatment. And we do this by putting together projects or multiple technologies and providing custom solutions. We also have a large line of technologies or skidded equipment that we could provide robust water treatment with. And then, of course, we support these two areas with first-class services to our customers. And we work in a wide variety of industry, almost every industry on Earth, including municipal, industrial as well. And you can see some of those listed there on your screen. Well, great. I'm going to hand the webinar over in a moment to Matt Chase. We just introduced the two panelists that we have here. Matt Chase will be our main panelist for today. He has over 25 years of experience with Veolia Water Technologies. He's been involved from everything from chemical services to managed operations and also technology and equipment sales. And then some background on him. He's a chemical engineer from Michigan State. So we're going to learn a little bit more from him, but he's a critical person within Veolia Water Technologies and supporting people and industries with their water and wastewater treatment by implementing first-in-class, robust water treatment equipment. Also with us is our product manager, Michele Gallucci. He also provides a lot of support to all of the companies within the United States and Canada looking to improve their water and wastewater treatment with a variety of technologies, including evaporation. So we'll have him around for the question and answer session. So at this time, I'm going to hand this webinar over to our main panelist, Matt Chase. Matt, can you hear me?
Yes, I can. And thank you, TJ, and welcome everyone. Again, I'd sort of follow up what TJ said, is that we'd like to thank everyone for taking time out of their schedule today. We're all very busy these days, and I appreciate your time. And just for today, a quick overview of what the agenda is for today. Again, just sort of the general questions, why evaporation? Where does it make sense? Some of the various industrial applications that this fits into. Then going over some of the different technologies that are out there to deal with evaporation. And then the different styles and models that we actually supply, some of the advantages, and then we have a number of case studies. And then the main thing at the end is obviously feed us any questions. We certainly want to have this. This is something that we typically get a lot of questions on. We'd like to go over that. So thank you. All right, so I guess this is always the big question. Why evaporation? Why would it make sense? And there's a number of key drivers, and especially for what we're talking about with you guys today in the metal finishing industry, it's typically most of the applications that we have seen this used for is where you have a high wastewater disposal and hauling costs. Typically, this is for water that you can't send to the POTW or you don't want to send to the POTW, and this is where this would fit in. Whether it could be, obviously, that's all related to some environmental compliance. And then there's always the situations where it's just sustainability. There could be a corporate driver for water reduction or waste reduction, emissions, and just general footprint of your process. And then the last one, and again, this isn't necessarily the one that we see all the time, but it comes up quite a bit, is whether it's a byproduct or, again, recovery option of some metal or something from the process, or how, depending how important it is to be able to reuse the water that you have. Okay, so typically where the evaporator fits in, it's where you have hard to treat wastewater, or that it's a process that cannot be disposed of through your normal disposal methods. And then another key area would be, again, if typically we're looking at low volume water, whether it could be some side stream of a process or just overall low volume of discharge. Typically our largest systems are going to run in the range of being able to handle anywhere between 15 and 20 gallons per minute. Again, as we talked about, is the main thing. Again, it's just the focus on these things are typically always reducing the disposal costs and the volume. So let's say, generally we could be looking at a 90 to 95% recovery. So instead of disposing, your full load, you're now reducing that volume down substantially. Other situations where the site is required to have zero liquid discharge, again, water reuse or potentially metals recovery. And depending on the process, typically, we've seen the nickel, cadmium, chromium, and copper. Some of the different applications, and we have case studies for almost every application that's out there. Some of the different mechanical ones, and one of the ones that we see fairly common is some oil emulsions. This system can handle oil, but it has to be in the emulsified form, so it has to remove the free oil first. Different degreasing baths, phosphate baths, again, we can look through all these things. There's a number of just some of these different rinse water applications that this all fits in appropriately. But again, then the main focus is on the next slide is related to all the different surface treatments. And this is where we see it the most. This is the waste treatment from, either the rinse portion, some of the cleaning baths, all the different portions of that process where that water is then accumulated that typically cannot be disposed of offsite. So we sometimes, depending on the application, we also, and what the site's able to get rid of, we sometimes take RO reject and some of the demin regeneration from some of the various plants there when we're having to deal with a true zero liquid discharge site. But pretty much everything other than the concentrated bath are treatable for the applications that we're talking about here. Okay, so what do we mean by advanced technology vacuum evaporation? Well, typically, normally, water's not going to, under a vacuum, our water can evaporate at a much lower temperature. So typically there's two different styles where we're either dealing with something that's just slightly above room temperature, 80 to 90 degrees F. And then we have another application that we evaporate at a much higher temperature, 170 to 190. But some of the big advantages, it costs, we have substantially less energy needed to run the system, substantially lower boiling points, so there's some corrosion reductions in the temperature that we're running at. With it being a vacuum evaporator, there's little or no oxygen available, so reduces the additional pitting corrosion that can take place. And then the best part is for us is these things is that there's no true air emission. So there's obviously a distillate stream and a concentrate stream off the system, but there is no emissions from either a heating application where you need to have run with natural gas or something else to generate heat, or any of the evaporation byproducts. Everything is collected in a closed loop. So here's sort of just one of the typical overviews of the metal finishing and what we typically see in our applications. You know, as I mentioned before, one of the important things, if this one happens to be for an oil emulsion, one of the critical things on this is to make sure that the free oil is removed. Anything that basically can disrupt the surface tension and reduce evaporation rate. So remove the emulsified oil, or remove the free oil and feed the emulsified oil to our system, typically anywhere, this one's listed at 97% recovery of the influent volume. We're getting about a 90% overall recovery on the distillate. And then the concentrate has a little bit of oil in the concentrated stuff. But again, the critical part in this thing is to make sure we have the oil out of the system. But this is sort of the general rule of thumb for most of the finishing processes that we're seeing, around an overall 90% recovery of the system, which again is just going to dramatically reduce your hauling costs for this application. So again, really how and where is Evolut applying? So it's typically, fits into a larger process. It's not meant to be, full standalone on it, but it's typically can be used in the final concentration after like a UF or RO. If you're using it in a wastewater application, that concentrate stream could then feed to an evaporator for either ZLD or near ZLD applications, or within a complex plant that has some physical or chemical, physical or biological things where it can help with some small waste stream or some small process that can work within that. Again, where we typically see it though is again as a standalone, typically for disposal cost reduction or typically some byproducts recovery. So some of the different types of evaporation technologies that we have, and these are the three families, and generically the three style ones, and we classify them PC, which is our heat pump system, which is the one that we're going to see almost 80 to 90% of the applications that we're going to be dealing with. That's typically what the piece of equipment that we would be using. The next one is the AC, or the hot and cold water or cogeneration system. Thing to keep in mind on this is this does require hot and cold water to feed it. All the other evaporators are all electric, so there's a little bit of additional need on this thing, but this is typically used in the application where we're going to go to ZLD, where we need to actually make a crystal or a solid product as our waste stream. The last one is our RV, or the mechanical vapor recompression system, and this is typically done. This is by far the most expensive system, most energy efficient system, but it's also a little more higher maintenance involved, but it handles a much higher flow rate. So depending on the right application, this can fit if we have a much higher flow rate need. So starting with the PC unit, or the heat pump evaporator, this is typical for a system for small flows and very small flows at up to about 4.4 gallons per minute. The one thing to keep in mind on all these rated capacities that we're mentioning here is that they're all rated on distillate production, so not necessarily on feed water. So, again, if you have something that just, for example, if we're running it at 5 gallons a minute feed and we're doing an 80% recovery, it's going to give us 4 gallons a minute of distillate. So that's just in general. So when you look at this thing, just keep that in mind, that it's not feed rate, but distillate production. As we mentioned before, this runs at basically slightly above room temperature. And again, there are two styles of this. There's the PCF, which is sort of the forced recirculation. That's our normal system. The PCR is a scraper system, and in some situations it can be used with high solids, and it can also make a very concentrated sludge, almost to ZLD, but for very small flow applications. The one thing to keep in mind on this unit, again, it's all electric, it's all skidded, self-contained, and it has a refrigeration system that does the cooling for the process. The next one, again, is the AC. And again, typically this is only typically put into use for applications that we have a need to get to ZLD. There are some rare situations where we can use this as the initial concentrator section, but it would be in a situation where the plant had, again, let's say it was typically in a larger industrial facility where it had actually hot water and chilled water available to be used. But again, typically this is just for making a solid and zero liquid discharge. This can actually handle slightly higher flows up to about 11 gallons a minute. But again, it evaporates at the same 80 to 90 degrees F. There. Okay. And then our last system is the RV series, and this is a mechanical vapor recompression evaporator. This one is for higher flows, up to 22 gallons per minute. So where I would say the first two units are completely almost hands-free operation, very limited maintenance, very limited oversight required. The RV unit is certainly very energy efficient, but it requires a little bit more maintenance attention to it. But again, it is in the right application, this is certainly the right technology in that it runs very energy efficient, about 3 times the efficiency of the other units. Again, it has 2 series. There's a natural circulation flow, and typically that would be with exhausted oil, or different oil emulsion systems. But again, most of the times we're going to be looking at the PC for those applications. All right, I'm certainly not going to go through all the whole list of here, but there is an evaporator that basically can handle almost all of the wastewater applications that you're looking at, again, within the right flow range where it would make sense. But we have, and Veolia has thousands of applications out there, and we can match up the right unit and probably give you a case study or an example for all these applications that are out there. But again, so then some of the advantage of it, again, this is pretty much a plug-and-play system. All of our systems are supplied skid-mounted, ready to go. There's just typically piping hookups and electrical hookups required for this. Again, the big advantage that we talked about is there's no emissions. So there's no air permitting. Typically, the only permits that I've ever seen anybody have to do is that if it's part of a process and they're requiring documentation associated with it. But in most situations that we've ever dealt with, and again, it's from California to some of the easier permitted states, we haven't had to deal with any emission permitting or air permitting for these units. Again, plug and play. Typically, again, power in, controls in, piping in and out, and it's very simple to install and get up and running. Relatively small footprint compared to comparable technology. Again, fully automated. It's ready to go. And then we have some reduction, obviously, in carbon footprint compared to another evaporator that would have to be dealing with having another heat source to heat the system that's not running at the vacuum that we're running at. Okay, zero liquid discharge. And again, this is where we're talking about the AC units. This is where we'd have basically, so the ACR style would be with a scraper mechanism on it. This would be able to take, typically the way that we operate these is that we run from a concentrated stream. So typically from an existing evaporator would then feed to this crystallizer section. It can get down to 90% of dry matter. Now, again, we'll have to do some testing to confirm what the maximum is, but that's typically what we can get it to. But again, this further reduces the volume and the disposal cost and typically gets you down to zero liquid discharge. There are some applications that we run where this solid is actually a recoverable material. All right, there's a number of case studies that we can walk through, and there's certainly more that are available. So certainly if you guys have any questions of where you're at on applications, we can go through that. But we've got 4 or 5 in here that are really applicable. Again, as we mentioned, I said there's 1,000. We have over 4,000 global applications. We just put a quick slide together here of where just some of the bigger systems are that we have in the United States. This certainly is not all of them, but you can see it's across every industry and across virtually the entire country. And again, again, if you need some other list, but basically we've dealt with every major company out there, from automotive to pharma to food and bev to oil and gas. And again, we have a few of these products here. So the first case study is at an aerospace company. They have, as we'll pretty much see in all the applications, very high costs related to one of their wastewater streams that needs to be shipped off-site. And there's a big corporate initiative, obviously, to continue to reduce the waste impact on their site. So again, this is again a surface treatment process. So we're taking the sort of the effluent of their initial treatment plant and feeding it into our unit. We are coming in, you know, this is the PCF 6 unit. So we are typically rating this one, we're getting to about a 95% recovery. So about a gallon per minute of distillate. And typically most plants were using that distillate to feed back to the front end of the process. It can be used to go either as makeup back to the plating bass, or depending on the quality requirements, it could go back to the front end of a treatment scheme, you know, prior to RO or prior to DI tanks for reuse. The concentrate, again, is then collected, and this isn't required to be ZLD, so they're just shrinking it down to as far as possible and then hauling that off-site. So that was our original design, and we actually came up to being just a little bit better than we thought. So about 90% recovery on the water used. So about a 10 times concentration factor. The overall payback after installation and startup, it was about 14 months. And again, that's varying quite a bit, certainly as hauling costs are getting worse these days, and nothing's getting cheaper to run. This is probably even gonna be better paybacks in a lot of situations. But this one, they yielded a total 85% disposal in their cost reduction on their wastewater. And again, they were able to reuse the water back into the process. The next one is at an automotive parts company. Again, this is for alkaline washing waters from the metallic parts. And again, this is where we see a lot of our opportunities, and so probably the higher percentage of our units within to basically different parts finishing plants, and typically they end up being automotive plants. This one, again, as we said, this is a PCF, and this is typically what we're going to be using. This one has a it's a little bit smaller one, the 1.4, and you can see by the labeling after that, the AA. We have different materials of construction. We'll get into a little bit more details on the evaporator and some of the selections you can have for that. But this one has a little bit more solids in it. This one has also fairly high conductivity for what we're trying to do. But this one, the overall reduction, again, is that we got up to, again, this is a very small system, only about 198 gallons per day, but it was, you know, the reduction in fewer, and in the future, the plan is that this site is actually to have an additional treatment plant after this to be able to handle this concentrated waste stream. So in this one, the overall recovery was about 75% of the water was able to be recovered. Again, a smaller concentration factor, obviously just 4 times, but again, typical payback is typically always less than 2 years for sure. This one is around 16 months. And again, with this, as you can see by this picture, it's a very small footprint to handle this, so we're not taking up a lot of space on the production floor to be able to handle this. It's certainly better than a full-scale waste treatment plant. The next one is a plating application. They produced products for use in office furniture and upholstery, some different building and machine manufacturing. This is a nickel plating wastewater, heavy in metals and the chlorides. Customer wanted us to design a ZLD for this application and try to recover the nickel. So again, this is a different material construction. You see it's the HH on this one. It's a PCF4 HH, so it has different material construction than the other one because of the pH of this water and the content of what was in there. You can see that we started with a much higher conductivity. So we were trying to, in this application, be able to recycle some of the water that's concentrate from this back to the plating line. So the goal of this, again, was to reduce all the waste that are hauled off site and to recover the nickel, which is what we were able to do on this application. So again, since we started at a much higher conductivity or TDS, our recovery was around 70% up to 75%, so 3 to 4 time concentration factor. Payback of this was 2 years, but what we were able to achieve is that this was now a zero liquid discharge process. So from the concentrated bath, that nickel was 100% recovered back to the front of the process, and the water, the distillate, was then reused back into the front end of their system. Again, about a 2-year payback on that. So getting started. So as we mentioned, we have 4,000 applications out there. We've supplied an evaporator in almost every wastewater application you can imagine. So we have a very wide-ranging case study. So some of the easy things to do is if you have either the process or an initial wastewater analysis, we can help and do some preliminary evaluations. But if we get to the point that it's a more practical project, we have a lab that we can send a few gallons of sample to and run a true distillation test. We do full analysis of the influent, the concentrate, and the distillate to be able to show if it's and show full and actual recovery rates of that waste stream. So it's a great pilot to be able to do to assure you. But again, we can typically give you a good rule of thumb from your process that you're dealing with. And if you have a decent water analysis to start with, we can give you a very good idea of what the right equipment is, give a mass and energy balance prior to even this initial step to make sure that it's cost effective and feasible for you to do based on some of the initial evaluation that we can do before we go to this next step. Typically, it's a 2 to 4 week turnaround time on that lab testing. So sorry, TJ, I jumped around a little bit. Conclusions. So some of the key takeaways here, again, for the metal finishing business, the main key driver on this is the reduction of wastewater disposal costs, and basically doing that by reducing the amount of water that's disposed of offsite. This evaporator and our style of evaporation requires much less energy for evaporation, so a much lower operating cost. In most applications, just about all of them, the distillate is available for water reuse. It's not going to be as necessarily as good as DI water, but in a lot of applications it is close, and it could be potentially polished a little bit if it's needed to be a little bit higher quality. But typically it's as good as RO water quality as that you would have in your application. It can help you achieve different sustainability goals, or in the end, if you needed to be zero liquid discharge, this is certainly the right technology for you. And in the right applications, a byproduct recovery opportunity, whether it was nickel in our applications, we've done it on chromium plating baths before too. It's a relatively small footprint, certainly on the small flow rates, it's a very small footprint. And then we have basically the 3 main types of evaporation technologies available. All right, TJ, that's sort of wrapped it up for me. I guess we'll take any questions that we have.
Yeah, great. Thanks for sharing all that information, Matt. And now we're going to transition to our Q&A portion of today's Tech Talk. Again, there's a field on the right-hand side of your screen. Hopefully you can find it, but it's for questions. And go ahead and enter any question that you may have, and again, we'll try to get to it. We have a few to get started here that we received. Going through these. For our first question, Matt, how can you determine the recovery rate of the evaporator? Do you have any feedback on or comments or experience with that?
Yeah, so again, like I said, I think near the end of the presentation, there's a number of applications that we already have out there that are going to pretty match up pretty close to some of the wastewater streams that most people have. So we can, just with knowing the application, give you an idea of what the recovery is. But the next step would be, as we mentioned at the end, is being able to send a sample to the lab, and we can actually get an actual evaporation or recovery rate by doing it that way.
Okay. Another question is can you talk about the materials construction options and how are they selected based on the application? I guess McKelly, our product manager, might be the best suited for this question.
Yeah, here we go. Can you hear me?
Yeah, thank you, McKelly.
Yes.
Okay, so basically we have 3 different materials of construction. First of all is the stainless steel 316L. And we select this kind of unit when we have low corrosion wastewater, when we talk about low contents of chlorides and fluoride, and also with the neutral pH. And I would say the content of chlorides for this application, in order to apply the stainless steel, is around 3000 ppm. If the water contains, and even during the concentration period, the concentration step, we're going further than this, we have to go with the second material, that is the super duplex. And the super duplex can handle up to 200,000 ppm of chlorides. So very high concentrated and then very high corrosive material, corrosive wastewater, and even at a low pH. Last but not least, when we have to handle with very high corrosive, so chromium plating line or for fluoridic acid, we have to go with the alloy. And in that case, we don't have any limits, because the alloy is almost inert for any kind of corrosion. So these are the three materials that usually we made our unit.
Great, thanks, Michele. Another question that we have in the queue here is, one of the attendees said they saw a vent or a chimney on the photos of the evaporators presented. What is that chimney for? Because we've mentioned throughout the presentation that this is a no emission closed loop process. I don't know if you could comment on that, Matt.
You're saying chimney, like is that what they're saying?
Yeah, one of the attendees saw a chimney on one of the photos, but I guess can you just comment on if there is any type of emissions or safety that allows for some kind of emissions?
I will answer that. There is yes, it's not a chimney, it's more a safety relief when you have to break the vacuum and you have to discharge the water or do any kind of maintenance. But there is no any air disposal or air outlet or vent in our unit, because basically we don't have any evaporation of that goes into the atmosphere.
Okay. And the question that came in is this system in place anywhere treating a painting process? Can you comment on that?
Did you say painting or cleaning process?
Painting.
Well, I mean, I guess it depends what we're classifying as painting. We have it on a number of e-coat lines, but not on that portion of the bath that actually has that e-coat solution. So I've proposed them and sold them into the cleaning portions of that process prior to the e-coat system.
I have
Not
this
sure
question.
if that fully answers what is. Yeah, go ahead, Michele.
I have that one. Because we have application in painting. So or in Italy and in a couple of projects in Germany, we have application in painting line. So yeah, it's something that can be treatable.
Okay. A question talks about the power consumption. Have you had any idea or numbers or data on the power consumption per liter of raw water or influent?
Yes, and we'll share that information out of here. Each of the cut sheets for each of the different pieces of equipment have a rated power consumption per liter of distillate. And again, as we can get into different applications, we can do a much more thorough mass and energy balance with the actual characterization of the water and the if we do an evaporation test.
Okay. And we could send that out after the event too, to the person that was asking. And then, this is an interesting question. Talking about metal recovery, what is the downstream processing for metal recovery, if that was a desired benefit of this system?
So, Michele, I can hit it too, but do you have a good example of that?
So they are asking why the customer.
No, what's the downstream of, is there something downstream of the evaporator? And typically there's not. We're dumping the
No,
concentrated solution back to the plating
not
beds, right?
downstream. No. The concentrate just they just dump they send the concentrate back into the plating line without any treatment. Yeah, you know.
And I think there are some applications that we have that when we go to the crystallization step, that product that's generated is a recoverable solid that's in there. Now, it might have to go out for an offsite for reprocessing, or sometimes it's a straight sellable product.
Yeah, correct. It depends about what they want to do with the concentrate. Because if they want to resell, maybe it's better to go solid and then sell it. On the other hand, if they want to reuse in their plating line, mostly, I would say almost 100% of our customers that they are using this kind of application in plating line, they send back the concentrate directly without any treatment, or just maybe or heating up or cooling down the water. It depends about the temperature of the bath. So that's the only treatment that they do.
Okay, great. Thank you both. Question for you, Matt, is could this system be used to recycle wastewater from a CNC machining company that uses coolant emulsion and also water from parts cleaning with soapy water?
So I guess that's a pretty open-ended question. We try to segregate the waste streams sometimes, depending on how we can do it. I mean, certainly anything that has a heavy foaming tendency, we can feed anti-foam to the system to be able to run it and recover it. Typically, we're able to treat pretty much anything that comes to it as long as it has some kind of consistency to it. So we certainly want to collect it in an EQ tank and then feed it from there. I don't know. Do you want to hit the cleaning, any points of that, Michaela?
Oh no, basically I would say that as you say, we can segregate the water and treat differently. But on top of that, we have customers that they blend together all the waste, CNC machine that coolant, spent in coolant, everything with oil emulsion basically, plus or the CIP or the cleaning or the rinsing water, and they mix all together and treat with evaporator, and basically just with the antifoam as chemical, we can rid of this waste easily. It's our, I would say, bread and butter overall in our 40 years of experience on that.
Okay. Another application question. Michele, do you have any knowledge of the evaporation technology Evalet being installed at a photo finishing lab?
Oh yes, Evalet just started and born as photo finishing application. So in photo finish application. So this was 40 years ago. So now I guess we have more, less application in that because we are just expanding our market. But yes, we can apply in photo finishing plant as well. Yeah.
Okay. Michele, a question for you is can you talk a little bit about how the corrosion resistance and materials of construction are selected? I know you touched it pretty well a moment ago, but just maybe highlight quickly on how they're picked.
Oh, basically. So if we have chlorides content in the concentrate up to 3000 ppm of chlorides only, or the sum of chlorides plus fluoride, we can go with the stainless steel. So our standard stainless steel 316L. On the other hand, if the chlorides content is higher than 3000 and can go up to 200,000, we can go with the super duplex. That is a nickel alloy stainless steel, very high resistance to the corrosion, and is, let me say, is another standard for us. So very easy to handle without any issue. So, and we almost have, I would say, 60% of our application with high content chloride with this kind of material. And on the other hand, last but not least, when you have to treat, with very high corrosive, very low pH, or also chromium 6, or very, very acid waste, we have to go with the Hastelloy. It is another, uh, um, stainless steel, but very, very high resistant to the corrosion. So basically, this is our materials of construction.
Great, thanks, Michele, for that. Another question is can you talk about if the unit is expensive or any costs?
Well, so let's just, I guess we can just try to give order of magnitude costs, right? So the PCF unit from the smallest size in the $75,000 range up to the largest side that could be $400,000. The RVF varies from probably $300,000 to $1 million. So that's ballpark costs on those systems.
Okay. And the question is what is the common ROI or payback that you see from an Evalet evaporator?
1 to 2 years.
And
we've seen it, again, it all depends on where you're at, but that's sort of a good rule of thumb. I've seen things less than that, and we've seen some slightly higher than that, but 1 to 2 years is a typical good rule of thumb. Installed.
Okay. And another question that came in is what kind of process do you have in place to make sure that the results are as expected?
That sort of leads into what we had talked about a little bit earlier, was that we certainly have a good reference or case study based on applications. So that's our first cut point, and then the second one would be sending the sample back to our lab to run full-scale bench testing, and that's typically what we do to try to reassure and assure the results that we're going to get on recovery. Again, we also have a startup and commissioning team that's there to help start up the system, make sure that it's meeting the recovery on that. But again, the whole key on all these things is to try to have a consistent waste stream feeding it, and then being able to match what we can say what we're going to do.
Can you talk a little bit about the operational maintenance for this particular technology?
Yeah, so like I'd mentioned a little bit before too, the PCF unit is really truly a hands-off process. Depending on the application, there might be some limited cleanings quarterly, annually that might be required on that system, but we have any number of cases, and Michele probably has a better list than I do, but I know of 2 right off the top of my head that have been running for 30 years that are still in functional capacity. So with very little, if any, parts replaced other than seals and gaskets and recharging the refrigeration unit. So as you get to the other units, certainly up to the RVF, where you have a blower that's on there that has some maintenance requirements depending on the application. It could be as long as every 3 to 5 years to as frequent as every year, changing the blower and sending it out for rebuild. But that certainly requires again, what I would say is my rule of thumb that I've told people is that if you have a PCF unit, somebody's taking a reading a couple times a week and just watching it to make sure that it's functioning properly. The RVF unit, you're typically having somebody taking readings multiple times a day, just taking a look at it. And again, everything's collected on the screen so you can monitor all the data, but somebody definitely needs to look and review and make sure that it's functioning properly.
Great. Well, it looks like we got through most of the questions there, and we're right on time, right on schedule for today's webinar. I want to thank both Michele and Matt Chase for providing their insight and experience and case studies about this particular application for this industry. I want to also remind everyone, after the webinar, you'll be prompted to take a survey. Please take that survey, and again, we'll enter you in for a drawing for an Amazon gift card. I'm really appreciative of everyone that spent about an hour every day or so learning a little bit more about this application, this technology. I just want to let everyone know that the recording of this for the presentation will be sent tomorrow, as well as your participation certificate, so you'll have that document to refer to. And again, if you have any questions, feel free to email me. I'll put my information back up on the screen. and look forward to seeing you at one of our future Tech Talks. Thank you all.